Hello, my name is Joe Murray. I am a gastroenterologist with the Celiac Disease Program at the Mayo Clinic, Rochester. The topic of the microbiota, or our own bacteria, that's our own ecology, and its role in human disease has become a major focus of scientific effort and popular interest. Celiac disease, which we know is triggered by gluten and affects people with certain genetics, also may involve the microbiota. In order to address this, a group from McMaster University in Canada, as well as from Spain and collaborators from the University of Chicago and myself, studied the role of the microbiota on gluten reactions in mice that are peculiarly gluten sensitive. These mice, originally developed here at the Mayo Clinic, were put into various conditions, things you can't do with humans, put into conditions of being germ-free, means they've got no bacteria at all, varying types of clean or perhaps not so clean environments, as well as treated with antibiotics. And basically the results of this study are a little complicated. So bacteria can be good or bad for gluten reactions. In some circumstances, some bacteria may suppress the immune response to gluten. But in other circumstances, bacteria, including a bacteria derived from a patient with celiac disease, may actually drive an increased immune response to gluten. Changing the bacteria with antibiotics may also change the reactivity to gluten. Now, what does this very basic science mean for people with celiac disease? Well, perhaps one of the things that drives celiac disease, either in an individual or in society at large, may be changes in our microbiota or our bacteria. These could be changes that are perhaps driven by exposure to antibiotics, for example, or perhaps naturally occurring changes that that may occur naturally, say during the course of time, or with exposures to different foods, or perhaps to other infections that pass through our system, changing the microbiota. This really opens up far more questions. Can we manipulate the microbiota in a way that would protect against celiac disease? Can we perhaps avoid manipulating the bacteria in a way that increases celiac risk? There's no doubt that this will be an area of continued focus, both using models such as our study, but also looking at patients, trying to identify perhaps what bacteria are playing good and bad roles in the disease. Thank you.